What's up everyone, Ali here. Today's problem is called minimum window substring and it's among one of the most challenging interview questions. It is also has been asked by a lot of companies like Facebook,
Amazon, Uber, Bloomberg, Apple, Microsoft,
and LinkedIn. Now let's solve the problem together.
The question says we have two strings S and T, and we should return the minimum window in S. So minimum window in S, which will contain all the characters in T. So we have to return the minimum window that contains all the characters in T. And if there is no such window in S that covers all characters in T, then we have to return an empty string. Also, there is a note section here that says if there is such a window, it is guaranteed that there will always be only one unique minimum window in S. And then we have the constraints about the length of the strings, and also it says that S and T consist of English letters. And on the follow-up section, it asked us to design and find an algorithm that runs in ON for this problem. But let's see an example to understand this problem better. Consider this is the S. This is the string that we have in S, and this is T. So we have to find the minimum window in S that contains all characters in T. But let's first talk a little bit about window and what is a window. A simple definition of a window could be a series of characters in a string. For example, this could be a window in a string. But if I choose characters separately from this string, these characters cannot make a window. There should be in series. So now that we understood the definition of the window, let's see if there is any window that contains all characters in T or not. So we have A, B, and C. First, let's find all the windows in S that contain these characters, and then choose the minimum window among those windows. So the first window that contains A, B, and C would be this one. So we have A here, B here, and C. So the first window would be this, and the size of this window is 6 characters. And the second window would be, we have B, C, and A here. So the second one would be this window, and the size of that is 8. And the third window would be this one, C, B, and A. So this is the third window, and the size of this window is 6 again. And the last one is here, B, A, and C. So this is the last window, and the size of this window is 4. So as we are searching for the minimum window, we have to choose the last one, which has the size of 4, and it is B, A, and C. Now that we talked about the problem thoroughly, I will explain the suitable algorithm to solve this problem on the next section. To solve this problem, initially we need 2 pointers to iterate the string. I call them left and right and show them with L and R. And initially they are both here. And the algorithm works in this way. On each iteration, we move R by 1 to find T characters in S. And when we find them, we try to minimize the window by moving L through R. Then we do this work again and again to find the minimum window in S. And to do so, we need to keep several variables. First of all, we need a map of characters to integers in order to keep track of the number of each character in T. For example, now we have A, 1, so because we have 1A, and B1 because we have 1B and C1. Then we need a variable to monitor number of characters in T that we have to find in S, and I call it T character count or TCC, that initially is 3. So we have to find 3 characters in S. We also need a variable to keep the minimum window in S containing all characters in T, which is our answer, so I call it answer. Now let's apply the algorithm to this example. So as I said before, first of all, L and R are both here. So we don't have any characters in the window. Because keep in mind that L is inclusive and R is exclusive. So for example, when R is on O, the window is A and D, or when it's on B, our window is ADO. So now let's start it. Okay, so on the first iteration, we move R by 1, so R is now here, and then we have A in the window. And A is one of the characters that we want to find. So I update the number of A and turn it into 0 because I found 1A. And also I decrease TCC by 1 because now I need to find 2 other characters, B and C. And I keep moving R by 1. Then R is here, so we have A and D, but we are looking for B and C, so we continue. Then R is here and we have ADO, no. Then R is here and we find B. So we update B on the map and also TCC. And again, we move R until we find C. Then R is here, so we have E. No, we are searching for C. And R is here, so we have C. So now we have found a window containing all T characters in S. R is here and the length of this window is 6. Now we try to minimize the size of this window by moving L through R. So we move L by 1 and L is here, and as you see, when we move L here, A is removed in our window. So we have to update the number of A in our map, and the way that we calculate that is that we subtract the number of this character in T, which is 1, with the current number of this character in the window. So as the current number of A in this window is 0, and 1 minus 0 is 1, so the new value would be 1, and also our TCC is 1 now, because we need another character, which is A, to have all T characters in our window. So as we lost A, we have to stop here and again move R. So we move R by 1, and then we have O, so we continue, and R is here now. We have D, as we don't have any D in T, so we continue. Then we have E, we continue. Then we have B, another B, so we have 2 B's in this window. And again, we have to update this. So 1 minus 2 is minus 1. 1 is the number of B in T, and 2 is the number of B's in this window. So it's minus 1. And yeah, TCC is the same. Then again, we move the window. Then again, we move R by 1. And R is here. Now, again, we have A, so we update that. And it will be 0. And also the TCC. So R is here now. This is the current R that we have. And as you can see, L is now 1 and R is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. So the current window that we have, the current size of this window is 10, and as it's bigger than 6, we do not update answer, and we try to minimize the window by moving L now. So L is here now, and we move it here. That's okay because we just lost D. Move it here. That's okay because we lost O. Here we lost B, but we have another B. And here we lost E, no problem. Here we lost C. So we have to, again, move R from this point. And so then we move R by 1, and R is here. So we have N, but we are looking for C. And sorry, I forgot to update this. So this is 1 now, and also here is 1. So R is here. We don't have any C, so we can move R by 1, and R is here. We assume that we can move R in this location. So R is here now, and C has been added to our window, and we have 0, and also this is 0. And the length of this window, this current window, is L, the current value of L is 0, 1, 2, 3, 4, 5, 6. So it's 6. And the current value of R is, 13. So as you can see, the size of the window is 7. It's still bigger than 6, the answer that we had. So we try to minimize the size of this window by moving L again. We move L here, that's okay. Here it's okay. Here it is okay. And when we move it here, we lost B, and as we cannot move R anymore. So this is the last window that we have. So L is here, and the current value of L is 7, 8, 9. So it's 9, and R is 13. So the size of this window would be 4, and we update answer. And it is the minimum window substring that we can find in S that contains all characters in T. Now that we understood the algorithm, let's see how should we write the suitable code. The inputs are S and T, and initially I declared the map and filled that inside the for loop. So as you can see, I iterated through each character of T and then put its number to the map. Then we have a bunch of variables. First we have T character count, or TCC, that equals to the map size. Then we have L and R indexes that are the same as L and R on the algorithm section. And also we have LANS and RANS to calculate the minimum window substring in S. So we haven't LANS and RANS here, but we have an answer. So these are for calculating the answer and the minimum window substring. After these variables, we have a while loop, and the condition of that is while R index is less than or equal to s.length. So it means that while R is not here, because as I said on the algorithm section, R can move up to this location. In the while loop, we have two sections. In the first one, we check if TCC greater than 0, so it means we still have T characters to find in S. And if R index equals to s.length, so it means that R is here, that means that we cannot increment and move R anymore, so we have to break. But if not, we move R index by 1 and then evaluate the previous character at R index minus 1. And if it's in the map, we assess its value. If its number equals to 1, that means that we wanted to find that in S. And as we just found that in S, so we update the TCC and also its value on the map. The second section of while is for minimizing the window. So in this case, TCC equals to 0, and we want to move L, like the algorithm section, to minimize the window and find the final answer. Initially, we calculate current window and answer length. Then we update L and R ans with L and R indexes. If L ans equals to -1, which means we haven't found the answer yet, or current window length is less than the answer length that we have. Then we move L index by 1 because we want to find the minimum window, and also we take the character at L index -1, so the previous character, to see whether we have lost any characters due to L index movement or not, and if so, we stop moving L and we start move R again. So as you can see, we check if the previous character is on the map, which means we had to find that in S, and also if its number equals to 0, then we have to increase the TCC by 1 and put the updated value on the map again. But you may ask why. Well, let me explain that using an example. So consider before we move L or L index, L was here. And the character that we had was A, and it was also on the map. And its value was 0. So it means that we had to find that in S, but as its value is 0, so it means that we already found that, right? Now that we moved L, if the previous character is having such a situation, so it is on the map and its value is 0, we have to increase that by 1, and we have to update its value. Why? Because now that L is here, it's not in our window anymore. So we have to update TCC value to know that on the next iteration, we have to search for A2 in the new window. And at the end, we check if L ans equals to -1, so it means that we haven't found any answer. We return the empty string, and if not, we return the substring, the minimum window substring that we found using lns, rns, and the substring function. Now let's submit the code in LeetCode.com and see the results. So it's been accepted, and our memory usage is very good. As you can see, it's better than 90% of Java submissions for this problem. And now let's talk about time and space complexity. The time complexity of this algorithm is an order of length of s plus length of t. And that's because, as you can see, in this loop, we loop over t characters, so we have an order of t. And also, in this while loop, we loop over s characters. In the worst case, we loop over s twice, because in the worst case, we have to move r and l, both of r and l, to the end of the s. But as we want to calculate the time complexity, we take order of s. And the space complexity is the same because we just saved s and t in the memory.
Thanks for watching. Don't forget to subscribe for more videos. And also, if you like it, please share it with your friends. See you next time.